Hi, in today's video I'm going to be showing you something very cool. If you have a look here, we have a video and it's owned by my user. If I run ff play and press return, it's going to open the video and play it with audio.
This is 327. I'm going in.
Good luck.
Okay, at this point you're thinking, mate, are you alright? I've seen a video player before. That's not very impressive. I'm going to stop watching the video now. But what if I told you that this was a Linux Podman container running on Freebsd, mounting the Wayland socket and Pulseaudio socket into the container with no video driver installed in the container, and using the Linuxulator libraries from Freebsd to actually allow access to the GPU. That's a bit more interesting. So again, then I'll play this again and it'll still carry on working. And the trick for that is what I have over here is I have the Pulseaudio volume control application open. And what this does is this keeps Pulseaudio alive. So what I'm going to do is actually take you through this setup. So what I have here, if I increase the file size, is the setup for a RockyLinux Podman container on FreeBSD. And first of all, what we have is a .env file. And what you'll see here is host xdg runtime equals xdg runtime directory, host uid equals 1001, host user equals my username. And as I said, if I come back across to the container and run ls, you'll see that the Podman container has got the same username as I have on FreeBSD. So what we have got is the exact same user and user ID inside the container as on the FreeBSD host. And this is important for permissions, so that any files that we create in the container have the same UID and GID as on the FreeBSD host, which means you can open them on FreeBSD. So if I run lsl mount, you see same output. Yeah. So what we're doing is we're actually we're using this env file when we build the Podman container and actually setting the xdg runtime directory, which is the location of the Wayland socket. We're setting our UID and our username, and that is going to be used with the Docker file and the compose.yaml. And what we have down here is the dummy uvm.so, and this is built into the container when we build it, and actually gets the Nvidia GPU to work from the container to the FreeBSD host, much like you would be using the Nvidia container toolkit on Linux to provide access to the GPU. We're doing the same thing, but with a SO file. So let's have a look at the Docker file. So what you see up here is from RockyLinux 9.3. Now this is important because FreeBSD has something called the Linuxulator, which is enabled with Linux_enabled equals yes in your rc.conf. And what this does is actually sets up a RockyLinux 9.3 environment, which is required for the Nvidia graphics card. When you install the Nvidia packages for the drivers, you have to have Linux set up. So what we're doing is we're using exactly the same version of Linux in the container as is on the FreeBSD host Linuxulator. And what we've got down here is these things, arg, host UID and host user. And what we're actually doing is when we actually set the, when we build the container, what we're actually doing is passing in these variables so that the container will be built with the same username and user ID as on our FreeBSD host. Next, what we're doing is actually installing some repositories and packages. So on RockyLinux, which is basically like Fedora, you have to install extra repositories to enable non-free packages. So what we're doing down here is we've installed some repositories that allow us to pull in the packages that are required. And what we're doing is we're installing ffmpeg. And you can see we've got all these other packages that we're installing here, like OpenGL, libglu, libinput, Wayland utilities. And what this does is this installs the packages required for Wayland. And that's so that we can use the Wayland socket from FreeBSD, which is in the XDG runtime directory that is mounted into the container, that when we play a video, for example, it uses those libraries and the Wayland socket mounted from FreeBSD to play the video. So then what we do is we're actually creating groups and users matching the FreeBSD ID. So as I showed you in a previous video, you have the etc groups file. And what we're doing is we're using the same group IDs and UIDs from the groups file in the container so that we have access to the GPU. This is in combination with actually setting up some devfs.rules. So etc devfs.rules. And what you'll see here is we are changing the permissions on the Nvidia driver to mode 666 group video. Dev Nvidia. So root video. Okay, for these devices, and that is the local rules. And then we have a rule, a dev set rule for JL4, which is the rules that will be applied to the Podman container, because Podman containers on FreeBSD are what's called OCI containers, and they're basically using a jail. So we can use the same rules that we would in a jail on a Podman container. And what we're doing is we're unhiding the mixer, the Nvidia speaker, and this allows us to actually have access to the hardware on FreeBSD from inside the container. So what we're actually doing here is we're adding various groups that allow access to the video driver, the video group on FreeBSD. And you'll see we've got 44. You see group add host UID and host user. And that comes from the environmental variable file that we created, the env file that has got our ID and our username in it. So what that does is that's going to create a group with our username and ID in the container. So it matches the permissions on the host. Then what we're doing is we're adding the groups for Pulseaudio, and what we're doing here is, as you can see, user add host UID and host UID here. We're creating a user with the host UID and the host UID, which will be 1001. So I'll come back to here. Host UID, and there's host user. And that's what this is using. And you can see we're adding it to all these groups here. So we're adding it to root, to wheel, and the video group inside the container is 39, whereas on the FreeBSD host it's 44. So by adding both of those, that is what, in combination with the devfs rules that change the permissions on the Nvidia driver to be owned by root and video with permission 666, that's what 660. That's what allows access to the GPU from inside the container. And then we're adding the groups for Pulseaudio here. Okay, let me just zoom that out a little bit one time. So then what we're doing is we're setting some environmental variables. We're setting the library path. And what we're doing here is we're setting the path to the shell scripts and stuff basically in the container. And at the end, what you'll see is home host user bin. And what we're doing, as I showed you in previous videos, we're creating a bin directory inside the container that mounts a bin directory in the same directory as the Docker file, which has actually got a load of my FFmpeg Rust scripts for Linux. Now I can actually show you, should be able to show you one of those, scopes-h. Hopefully this will work, I haven't tried it as yet. So scopes, vector scope, agent 367, that should open up the scopes. We also have histogram, so scopes. Let's do S. Okay, so that's showing you that that's working. And what we've got down here at the bottom is user, host user. So the host user, again, comes from the .env file, which is my username. So what that means is it's setting up the container with the same username as on my host. Then we have the work directory. So when you enter the container by running podman, doas podman exec, it will actually automatically put you into this home username mount directory. And that is a directory that is mounted from the FreeBSD host into the container, so that we can put files in the mount directory on FreeBSD and they show up in the container. If we save things or process stuff in the container, we save them back to that directory and they're accessible on the FreeBSD host. And then finally we have the entry point, which is bin bash. So that gives you a shell. Let's just have some tea. Next we've got the compose.yaml file. And what you see here is this is the name of the container GPU app. We've got image localhost Rocky local latest. And the reason for that is what we're actually doing is we're pulling down the RockyLinux image, but we're building it locally using the Docker file so that it is built with the same user ID and username as on the host. And what we're doing here is the platform, let me zoom it in a bit for you. Platform Linux AMD64, the container Rocky Podman, user root, and this is required so that we can execute root commands when it's actually built, but then it drops down to your user. OS Linux, network mode host, so that uses the networking from the host. And what you'll see here is Compact Linux user lib64. This is the Linuxulator directory on FreeBSD with all the libraries for the Nvidia driver. And what we're doing is we're mounting that as read-only to user lib nvidia-host inside the container. And the reason why we're doing that is we're not overwriting the existing libraries inside the container. We're creating a new directory with additional libraries from the FreeBSD host. Next, what we're doing is we're actually mounting the Nvidia-SMI to use a local bin Nvidia-SMI. So if I run Nvidia SMI, bang, you'll see the drivers, Cuda coming up. So Cuda is working. And as I said, the mad thing about this is there's no Nvidia driver installed in the container. It's using the libraries that we mounted from FreeBSD to have access to the GPU. And this is important because what it means is, unlike the way I was doing this in a jail where you had to install exactly the same driver in the jail as on the host, which is a real pain because you've got to do it manually and have to uninstall the driver and install a new version if you update it on the FreeBSD host. You update the drivers on the FreeBSD host, they're automatically picked up inside the container. So you don't have any issues there. Next, what we're doing is we're loading the dummy uvm.so from the same directory as the Docker and Compose file into the container at userlib dummyuvm.so. And this is used to intercept the Nvidia calls to the Nvidia-UVM device that doesn't actually exist on FreeBSD. So what this does is it sort of intercepts calls to that and tricks the container into thinking it exists so that the GPU works. Next, what we've got down here, I should need to change that. So what we've got here is bin home user host bin and mount home host user mount. So the host user is from the env file with our username that's from FreeBSD. So what this is doing is this is mounting the bin directory here that has got all my ffmpeg Rust Linux scripts in it that have mvenc support, so that you can use the hardware acceleration with the scripts. So it mounts the bin directory to home username bin, and what we were doing previously is we were mapping that to the shell path so that they're accessible inside the container. And then what we're doing is we're mounting the mount directory from FreeBSD to home username mount. Okay, so we are in home username mount. Same directory, you can see the same files. You can see the same file. So we mount the mount directory from FreeBSD to the container, and it could be any directory you want. You could mount multiple directories. This is what gives us access to the file, so we can copy stuff. We're not even copying stuff back and forth. It's just it's mounted in the container, so you've got access to it. Then what we're doing is, in your jail, when you create a jail, what you have is different device paths, sort of like compact Linux proc. And let me just come across to my fs tab, etc. fs tab. What you see here is for Linux, I have proc and f the script here. And what we're actually doing is we're mounting procs, compact Linux sys to sys, compact Linux devfd to devfd, and finally we've got this section down here that I'll explain in a second. So these are typically settings that you would use in a jail config. And as I said, Podman containers are actually sort of mini jails on FreeBSD. Then what we're doing is we're mounting temp to temp. So we're mounting the temp directory from FreeBSD into the container. And the reason that we're doing that is because what we do is we have a default.pa pulse configuration file on FreeBSD that includes the default.pa. And what this section down here does is it actually loads a module called Module Native Protocol Linux socket. And what it's doing is it's creating a pulse audio socket in temp called pulseaudio.socket. So what happens is once we have created that, and the way that we create, what we do is we actually start up Pulse Audio. Okay? And the way we start Pulse Audio isn't actually on the command line. And the reason for that is if you start Pulse Audio in the command line with Pulse Audio -- start, what happens is if you were using a GUI application launched from within the container, it would stay open and the socket would stay alive. However, if you're using command line applications, that's not the case. So what we do is we start Pulse Audio volume control on FreeBSD. And what this does is two things. It starts Pulse Audio, and because it's a GUI application running on FreeBSD that we leave open, it keeps the socket open, right? Because otherwise what happens is the socket dies after 20 seconds. So we have the default.pa on FreeBSD that creates the socket in the temp directory. We can then mount that temp directory from the host to the container. Then what we have down here is xdg host xdg runtime directory equals run user host ID. And so what happens is, back to the env file, you see the three settings: host xdg runtime directory equals xdg runtime dir, the UID, and the username. So if I come across here and run print env, what you'll see is the xdg runtime directory is var run xdg my username. And if I list that, var run xdg username, what you'll see in here is Wayland -0, and that, we come back up to here, Wayland display equals Wayland -0. Okay, so the Wayland display, as you can see here, is Wayland -0, and that is working using this Wayland -0 socket. You can see it's a socket because it has S in the permissions. Yeah. And what we're doing is we're creating this variable host xdg runtime directory equals directory xdg runtime directory where the Wayland socket is, and we are mounting that to run user host UID. So that's going to be 1001. So 1001. So the paths are different on Linux and FreeBSD for the location of the xdg runtime directory. So by mounting that directory where the Wayland socket is, that means applications launched from within the container, and because it has the Wayland libraries installed in the container, and what we do later on is in the shell configuration, we specify the xdg runtime directory location and the Wayland display. So what we have down here is the entry point and then the command. So first of all, what we're doing is we're echoing userlib64 dummyuvm.so into acclerated.ld.so preload. And this is the dummyuvm.so file that we built into the container using the compose file. And that is the location where it's installed. And by echoing its location into here, it means it's preloaded, so that the system has access to it. So now what this block of code does is it echoes a load of variables into the bash rc file in the container, which is the shell being used. So first of all, what you'll see is export LD library path equals userlib64 and then userlib64 Nvidia-host. So the first one is the default library path, and this is the library path that we mounted that contains the Linuxulator libraries that work with Nvidia. So what we're doing is, if I come back up here, compact Linux user 64 to userlib 64 Nvidia host. And so what we're doing is we're appending that directory that is mounted with the Linuxulator libraries and appending it to the library path. And this is essential because if you was just to overwrite the default path, it would break everything. But by using this method and saying, okay, the library path is the default library path and this library path, what happens is it will then look in this directory, find all the Nvidia libraries from the Linuxulator from Freebsd for the Nvidia GPU and be able to use them and have access to the GPU. Again, what we're doing down here is we're using LD preload and the location of the wvm.so. Again, just doubly to make sure that it's actually loaded. Then what we're doing is we're setting the path and we're appending home host user to bin. So that's going to be home, your username bin. And that basically, as I showed you before, we had the bin directory that we mounted from the FreeBSD host into the container with all the scripts in. And so that basically means you can use all the scripts that we've mounted inside the container. Then what we're doing is we're exporting the XDG runtime directory to run user host UID, which is 1001 set in the env file. And that is the location of the Wayland socket. And again, remember that we've mounted the XDG runtime directory from FreeBSD into that location on the container. And that's what allows the container to be able to see the Wayland socket. We then set the Wayland display to be equal to Wayland-0. The next one is SDL video driver equals Wayland. This is required for FFplay to be so that it works with Wayland, because by default it works with X11. And we're setting the QTA platform to Wayland and the GDK backend to Wayland as well, so that graphical applications will use Wayland as well. And finally, what we do is we echo all of that into home host user, which is our username from the env /rc. Next, what we're doing is we're actually creating the Pulseaudio directory. Let me zoom that out a bit. Inside the container, home username.config pulse. And what we're then doing is we're echoing default server equals temp pulse audio socket into the config pulse client.conf, and that is the configuration file for Pulse Audio that tells it where to look for the Pulse Audio server, which is the temp Pulse Audio socket that we have mounted from FreeBSD into the container. So when we open up Pulse Audio volume control, the GUI application, it starts up Pulse Audio, keeps it alive. The default.pa configuration file on FreeBSD creates the temp Pulse Audio socket. Then the client.conf inside the container then looks for that location, finds it, sends all the audio out the Pulse Audio socket. There comes out FreeBSD. Then what we do is we actually need to change the permissions on the user directory, the home for the user that we've created. So home host user, which is home. So you can see my home is owned by the same on the FreeBSD host. And we change the permissions on the bash profile and the bash RC, and on the config directory where the Pulseaudio client.conf file is. And then finally what we do down here is, because we started this as root because we need root access to edit the system files and stuff, what we're doing is we're executing su host user -c bin bash. And what this does is this drops the permissions down from root to the host user, which is a regular user that's got the same UID and username as on the FreeBSD host. And this section down here is to set up tempfs, which is also needed. So those are the files, and the advantage of doing it this way is because you build a container and then you can run doesnt podman compose up -d and then enter the shell. So the way that this works is what we actually do is first of all we're pulling down the image. So we pull down the image for RockyLinux, and we're actually building it here. doesnt podman build network host OS Linux. We set the architecture, and we set the host UID to be ID-U. So if you run ID-U, it gives you the ID. Do that in here in the container, got the same ID. And if I echo user, don't know why that's not working, but you can see what my username is here. And what we're doing is building a container called rocky-local. Once we've done that, what we do is we run doesnt podman-compose up -d. The container's built, and so it uses the compose.yaml file, mounts everything, sets the permissions, and then finally what we do is we run doesnt podman exec-it-u for the user. So this is going to be the user from the FreeBSD side. Rocky Podman is the name of the container. Bin bash gives us a bash shell, and automatically drops us into the mount directory where we can see the files. So what this basically means is, as I showed you, I've got Nvidia SMI working with Cuda. So you've got no Cuda on FreeBSD. But using this technique, running a Linux Podman container, we do. I showed you we've got hardware acceleration working. So I can run one of my scripts, trim clip -start in agent create a 10-second clip. And what you'll see is it will say hardware encoding, hardware acceleration. Bang, you see how quick that was. Now what I'm going to do is I will remove that file, and I have the same scripts installed on FreeBSD. However, as I said, we don't have Cuda hardware acceleration support. You've got the mv-sgl run command that kind of sometimes works with ffmpeg and then sometimes doesn't. And my scripts, my Linux ffmpegs or my ffmpeg Rust scripts have a hardware check to see if hardware encoding is available. So if I run trim clip s -t, 10 seconds, it will say software encoding. And you can see that takes longer to do than with hardware acceleration. Bang. And that's the difference. So I said, I've shown you we got Cuda's set up. We got hardware accelerated video. And now we have the Wayland window and Pulseaudio working. So we got the window will be created and the audio working. So this is the 10-second clip I just created. See there, it stopped. So, major progress. Took a bit of doing to get to this stage, but what that means is now I have full access to the GPU. I've got Wayland working, Pulseaudio working, hardware acceleration. So what we have here is a container, a Linux container without the Nvidia driver installed, using the libraries from Freebsd inside the container, using some configuration files. As I said, we got the .env, the XDG runtime for Wayland, the UID and the username specified, so that all the files are owned by exactly the same user. Yeah. And we've got the exact same username in the container as on the FreeBSD host. Nice touch. I do say so myself. Then we've got the Docker file, which takes the UID and user so that it's built correctly. We're installing all the packages for Wayland. We're creating all the groups to match FreeBSD. We're setting the library path, the path down here for the bin directory. We've got our host user, and we've got a work directory here. And this could be any directory that you want to mount. And what I may do is kind of abstract this work directory into a variable in the .env file so that you can specify in the env file the directory that you want to mount. And then we got the compose.yaml file, which is basically used to build. It uses the localhost Rocky local latest image that we build, platform Linux, OS Linux, user root, networking host. It mounts the libraries from FreeBSD, copies the shim across, mounts the bin directory and the mount directory, sets up the Linuxulator compact directories, mounts temp where the pulse socket location is, sets up the XDG runtime directory for Wayland, echoes all those variables into the bash RC shell, finally sets up the client.conf file for Pulseaudio so that it looks in the temp pulseaudio.socket for the location of the Pulseaudio server. We change all the permissions and everything works. So took a while to get to this stage, but what this now means is that I can take it to the next step and install graphical applications like Firefox and try and get DRM playback working in the Linux Podman container. But the important thing was to first, one, get Cuda working, get it to pick up Cuda. Then to actually get the libraries mapped from FreeBSD into the container, which I did in the last video. And then the next stage was to get Pulseaudio and the Wayland display working, which I just showed you, ffplay. So this is Agent 327.
This is 327. I'm going in.
Good luck, Agent.
And as you see, what we have is full hardware acceleration, and it's going to be useful for MPV and things like Firefox. And I'll just carry on playing this while I'm napping away because it's a good video. And what I'll also do is show you some of the other scripts.
Hello. I was just admiring the art.
So no stuttering, no playback. We also have real-time pulse audio set up as well, which
Please.
I can show you my
Such a lovely place you've got here.
root config
Is
files.
it usually this empty?
So remember, all this is playing from inside a Podman container. So all that is being played from inside the Podman container. The audio is coming out the pulse audio socket on FreeBSD. The video or the graphical interface is coming out of the Wayland socket on FreeBSD. You can also use an X11 socket as well, but Wayland works great these days on FreeBSD. It has done for several years actually, and the best compositor for FreeBSD for Wayland is DWL. I've tried multiple compositors. I've tried Kari, River, LabWC, that works pretty well. Wavefire, DWL. I think I tried a couple of others. I wouldn't bother with things like KDE. It's a bloated pile of crap. It breaks constantly, especially on FreeBSD. It's just not worth bothering with. So DWL is actually the best compositor for Wayland on FreeBSD, and I showed you actually how to get that installed in a previous video. So yeah, made lots of progress, and so what I'm thinking is I come across to Firefox, GitHub. So what I'm thinking, the best way to do this is rather than sort of building images sort of that you pull down, what the best thing to do would to actually be create a repository of different applications you can pull down using Docker Compose file, Docker files and Compose files and the .env, and you would build them locally. Like this. And the reason why we want to do it this way is because this is what allows you to set the host UID and host username in the Podman container to match the FreeBSD side. And if I was to do it another way, that wouldn't be possible. I don't want to build a container that is sort of hard coded. Now, the other thing about this is when you create a new account on FreeBSD and you've only got one account, the host UID is going to be 1001. You create another account, it's going to be 1002. And so the advantage of this technique is because we're actually using the ID dynamically, that doesn't matter. So rather than me hard coding 1001 in the UID and you having a different UID on your setup, this will pick up whatever your ID is. So my idea is basically to create a repository with directories for different applications with the configuration files in them. You could then clone the entire repository and then build the application that you want. So the applications that spring to mind, what I wanted to do, as I said, I wanted to first test this out with my of course here, ffmpeg Rust scripts. So these are the ffmpeg Rust scripts that I showed you where I was just trimming the clip. And these have nvenc support for Linux and Windows, but not FreeBSD and Mac OS X. And what these do is they've got different categories of scripts that you can actually do. Trimming and clipping, visualization and analysis, chapter and metadata, filters and overlays, color grading, conversion indexer, scene detection and cutting. So what we've got here is we've got a variety of scripts to perform different functions that you'd usually use a video editor for. So we've got stuff to trim clips. There's two different syntaxes. You can specify a trim clip specifies a start and the number of seconds after the start time that you want to record a clip from. So for example, 1 minute start time and an end time of 30 seconds creates a 30-second clip from 1 minute to 1 minute 30 seconds. Trim clips takes the start time and the end time. So if you wanted to record from 1 minute to 5 minutes 30, it'd be 1 minute and 5 minutes 30, which creates a 4 minute 30-second clip. We've got trim remote clip, and this works with YTDLP and Dino and allows you to trim a online clip. So rather than downloading the whole video, you can actually download a section of the video. We've got trim short, which creates shorts for YouTube Shorts and TikTok in the right aspect ratio, and also allows you to adjust the X position. So you can specify, suppose you had some action going on the left-hand side of the screen, you can actually specify X as 0, and it creates the short from the left-hand side, or X50 would be from the middle. We've got combined clips, which combines audio and video. We've got stuff to create waveform, the scopes I showed you, an EBU meter to show you the audio levels, creating contact sheets. This allows you to actually add chapters to a video without re-encoding, and also add subtitles to a video without re-encoding. We've got overlay clips, so it's like adding a B-roll. We've got overlay pip, which creates a picture-in-picture. X-fade clips, what this does is allows you to put transition between multiple clips. Got pan scan, zoom pan, which is like the Ken Burns panning and scanning over images. Got color grading, so that you can actually create a LUT and apply it to a video. And we've got stuff like audio silence, blur fill, where it adds the blur to like 4:3 videos instead of the black sidebars. Concatenate videos, delogo to remove logos, extract frame, extract a frame from the video. HStack puts two videos side by side. Image to video turns a still into a video clip. Obviously it's static, but that's useful if you want to concatenate images with videos. Normalize audio, sexagesimal time for working out timestamps. Vid to GIF creates a GIF from a video. WebP creates a WebP. And then we've got scene detection, which will detect the changes in a video and chop it up into various scenes. And so I wanted to start with these scripts first of all, because it proves that the hardware encoding is actually working. There's a good basis for then installing other applications like, as I said, Firefox. The other thing that will be useful is Alarma, because the version of Alarma in the FreeBSD quarterly package is 0.19, and there are some things like Gemma 4 that requires version 20 or whatever. So what we can actually do is run Alarma in a Podman container. We should also be able to run things like WhisperX, Handbrake, DaVinci Resolve would also be possible. As I showed you, I'll come back to my repositories. DaVinci Resolve, Freebsd, jail Rocky. Okay, and so what I was doing with this setup here, get DaVinci Resolve working in a RockyLinux jail, was I had to install the exact same drivers in the jail as on the Freebsd host, as I said. And that's a pain because what happens is you have to update if you update the drivers on the FreeBSD side, you've got to uninstall them in the jail and then manually install the matching version. And that has to be done manually. You can't use the version in the repository because they won't match on FreeBSD and on Linux. So the Podman solution that I've actually come up with is actually superior to using a jail because we are not installing a Nvidia driver in the Podman container, and we're using the Linuxulator libraries inside the container. And the other advantage is you can't distribute a jail. Okay, so the setup for this is all done manually. You got to kind of install the packages and stuff manually. Going through sort of, like entering the jail, running the commands manually one by one. So that's a bit of a pain. So the advantage of the of using Podman is that what you can do is you can create the env docker file and compose.yaml file and distribute it. You can then pull it down, build it, and run it, which is not possible with a jail. And so, as I said, what this means is it's going to be possible to create a Git repository with different applications with these files in it that you could then build and run as a native application on FreeBSD using a container. So there's the Pulseaudio thing still going. So again, my idea was basically to create a repository with different containers for different applications that you can pull down and build. So the next thing that is going to be interesting to look at is actually getting Firefox working. So because I've got to this stage now where I have got the access to the GPU, hardware encoding, got the Wayland socket for the window, I've got the Pulseaudio socket for the audio, and again, what you actually do is you open the Pulseaudio volume control PAView, forget what it's called, and what that does is that actually starts up Pulseaudio. The default.pa creates the socket in temp. The client.conf inside the container then sees the location of that socket. So when any audio is played in the container, it goes out the socket and comes out of the FreeBSD side. The advantage of this is zero latency. Okay, it's using a socket, so there's no latency whatsoever. Not like the audio is out of sync with the video, and it's going to be essential for things like, well, watching videos and using video editors like DaVinci Resolve. And the other important thing about using this is, as I said, if you just run Pulseaudio -- start in the terminal, what would happen is with command line applications, the connection, the Pulseaudio server stops after, say, about 20 seconds when there's no activity. And so by having this application open all the time, it keeps Pulseaudio running and ensures that the audio carries on working. So it took me quite a while to figure out that was actually the best way to keep the audio open. I was trying all sorts of different things, but then I thought, basically what we want is an application that's going to open Pulseaudio and keep it running so that the socket doesn't die. What's the best thing to use for that? And I thought, well, just open Pulseaudio volume control and it will start Pulseaudio and keep the socket alive, and so it does. So now I've got to that stage. What I can do is if I come into the Docker file, I've got everything set up. I've got all the audio set up and all the libraries and packages needed for Wayland. I just need to install Firefox here. If I create another, copy this directory and just append Firefox to the list of packages installed, I should then be able to run Firefox in the container and have it open the window and have the audio working and the video working. The next step would then be to create a desktop entry for FreeBSD that actually would run this. So instead of actually having an entry point of bin bash, what we'd have is an entry point of Firefox. So what we do is you have to run Podman with DOAS, and what I have is the etc DOAS, user local etc DOAS. What you can do is with DOAS you can set it so that it doesn't require a password, and we can actually set that either globally so that you don't have to enter a password for any commands that you use DOAS with, but also for just the Podman command. So what that allows you to do is create a desktop entry file that would be going in .local share applications, called something like, you can, rather than calling it Firefox and it mixing up with the default Firefox on FreeBSD, you call it Podman Firefox or DRM Firefox or whatever. I haven't decided, but you would have a desktop entry, and what the logic would be is you'd need to first of all check if the container's up. If not, bring it up and then execute the command to start Firefox. So that basically what that would do is means that you would just open your application launcher, type Podman Firefox. It would it would start up the container, open up Firefox in a Wayland window with Pulseaudio working, and you should be able to get DRM playback. The other thing that I was just about to mention that slipped my mind. I'm just trying to think what I was just about to say something. There is on the sort of the technical side of things. Oh God, I was going to mention something, but totally slipped my mind. Yeah, there are sort of things you kind of got to sort of get working. So there's sort of quite a bit of, you got to set up, obviously you've got to set up Podman on FreeBSD, but I've shown you that before and I've given you notes so you can get set up. But basically what I'll do is when I create the repository, I'd include the setup notes for setting up FreeBSD. All the configuration files are needed. Like in your etc rc.conf, Podman enabled, the various sort of settings that you would need, stuff in your KLD list, setting up Wayland, Linux enabled. Obviously, you need Linux enabled equals yes, and also setting up. Let me see if it's in the. Oh, come on. Okay. sysctl, sysctl.conf. All the sort of audio settings, like we've got audio tweaks to improve buffering and stuff like real-time audio. So that's sort of required for getting the audio working without any latency at all. But as I said, next step would just be to append Firefox to the list of these applications, and first of all try it by running Firefox within the container, and the next step would be then to create a desktop entry that, as I said, would start the container and then run Firefox automatically. But that should be possible. I don't see any reason why it wouldn't be, and hopefully I can get DRM playback working in Firefox as opposed to using the sort of various hacks. There are you've got the Widevine CDM, is it? And the foreign CDM that work with Chromium on FreeBSD. But the issue with that is you've actually got to use Poudriere to build, or ports to actually build some of those things, because they're sort of non-free or license issues. And it only works with Chromium, and Chromium is terrible because it uses the manifest v3 for add-ons, which means uBlock Origin doesn't work. You have to use uBlock Origin Lite, which doesn't block the adverts. So we don't like adverts. We don't want adverts at all when you're playing a video. Nothing more irritating than that. So, for example, on I'll go to channel4.com. For example, Channel 4 in the UK uses DRM playback. So does ITV.com. And they're also free to watch videos on YouTube, but they use DRM playback. So what this would allow us to do is actually have native DRM playback in Firefox with ad blocking without having to sort of jump through hoops. There is a thing, I think it's called something like Firefox OVM, is it? Firefox OVM. Forget what it is, but there's another project. There's basically, or I can't remember what it's called, but there's a way to actually get a file from an Android device and then use it with Firefox to get DRM working, but you don't want to go downloading shady files off the internet to try that. So this would be a much better solution if we could have a Linux version of Firefox that had DRM playback. The other thing you could do as well is you could even mount the profile from FreeBSD for Firefox inside the container. However, I've got my version of FreeBSD set up to use SND audio, OSS, as opposed to Pulse. So that wouldn't work in my case. But what you can actually do is, if I take you through to my FreeBSD.files, where do I, oh no, it's in, right. So what I have in my .files is, for Firefox, what you have is a couple of files. You've got the user.js file, the user chrome.css, and the user content.css. And the user.js file is used to specify options. So in Firefox, you may be familiar with going about, config, and sort of manually setting options in here for various things. What you can do is actually create a user.js file that does the same thing, and you can put that inside the Firefox profile, and this can actually do stuff like block AI. So, for example, down the bottom, scroll down to the bottom, block AI enhancements, browser preferences, AI controls equals false. So if I come to Firefox and come into the settings, normally what you will see is a section that says AI stuff, and it will say, do you want to disable AI? You see it's completely missing from my setup, and that is because of this. So I'll come into here. Okay, and you can see that's false. By default, it's true. And what happens is you get the AI controls thing come up. And so that option, basically, you put that in to Firefox and set it to false, it totally disables all the AI stuff. And basically the gist of this is you also have stuff like user Chrome, and this allows you to remove options from the right click menu. So you get like tons of options in the right click menu. Firefox, see, mine is nice and clean. So what is actually possible to do is actually copy those files into the Firefox profile to actually set it up. So rather than you kind of manually having to go through and sort of set things up, the only issue would be trying to figure out what the profile for Firefox in the container would be. But there probably be a way to do that. But basically the gist of that is that you'll be able to have a Podman container with configuration files for Firefox for the user Chrome and the user JS to actually specify a lot of the things that you kind of go through and do manually in the GUI, sort of enabling and disabling all these different options. Not all of them, some of them you still got to do manually, but a lot of them, like setting the homepage in new Windows to a blank page, that sort of thing, disabling all this kind of stuff, and that would make setting up Firefox nice and easy. So yeah, that's my thoughts on Firefox, and I'll upload the video and then get working on that, because I think that would be a good thing to actually try out. The next thing I would like to try out is Alarma, and as I said, you can then, if we use the Linux version of Alarma, we'll have a newer version than the one that is in FreeBSD, which will allow us to run models like Gemma 4. Now, Gemma 4 okay, models Gemma 4. Now, this is actually, I've only got 4 gig of VRAM for my Nvidia GPU, and I can't actually even run the 7.2 version. It's too big. But what there is there's what's called a GGUF, which is a quantized version that is a lot smaller, that will work on a 4 gig of VRAM, and you can actually build that as a local model. But as I said, that requires Alarma 20, and we're only on Alarma 19 on the quarterly branch. I think it's not going to be till the 1st of July in the next quarterly branch that the more up-to-date version of Alarma is going to be released. But basically, the quantized version is text only. Although Gemma 4 can do stuff like analyze audio, it's only like tiny amounts of audio, or it can analyze video, but like literally about a second. It's like basically it's a one frame. It presumes you're working on like a 1 frame a second video, which obviously you wouldn't be. So I did actually sort of try the audio and video, and it wasn't very useful. But Gemma 4 is actually good at tool calling. It's an agentic model, so it's actually quite good, and it'd be nice to be able to run this on FreeBSD as well. And using the GGUF and creating a model would allow you to do that, even if you only got something like 4 gig of VRAM for your Nvidia graphics card. So that's why Llama would actually be useful to set up as well. The other thing that would be good is WhisperX. I showed you in a previous video, we can actually set up Whisper CPP with Vulkan support on Freebsd as a native application, and that works really well, but it doesn't have speaker diarization. So by that, I mean it can't distinguish between speakers, where on WhisperX it will say like speaker 1, speaker 2, speaker 3. And that's particularly useful for transcripts or subtitles. So, say like you can then set it up so that you can change speaker 1, 2, and 3 to something like Rod, Jane, and Freddie, or whoever's talking. So WhisperX would be another application that would be worth looking at. So the other thing that would be also possible that I used on NixOS is Stable Diffusion and Comfy UI. Comfy UI. So Comfy UI, you may be aware of this. It's pretty cool. Allows you to actually create AI images. If you've got a bigger graphics card than I have, you can actually create videos with it as well. But it's really useful because you can actually also use it with things like Llama to create prompts and create anime images of foxes, which is maybe not what you want to do, but there's other things that you can do with it. You can actually use it to create really quite realistic images of stuff. I don't know if I've actually still got any of the images I created. I think I've got rid of them all. But yeah, this is another thing that would be really useful to be able to run on FreeBSD. And again, this is something that requires the GPU to do the heavy lifting, but it should be possible to get things like Stable Diffusion and Comfy UI working as well. So, as I said, the important thing was to actually get Cuda working, get all the libraries working, then get Pulseaudio and Wayland working, and that's all done. So the next step should just be a matter of installing the applications, and they should hopefully be able to work in Linux Podman containers on FreeBSD for full hardware acceleration, Cuda support, just like you were using Linux. And this is currently not possible, but now it is. Now, building on this sort of project that, as I said, originally I did using jails. I've done RockyLinux. I've done DaVinci Resolve using the Linuxulator. Done it with Ubuntu jails. I've done it with RockyLinux jail. So from what I've learned doing that, it was actually a couple of years ago. I've transferred that knowledge to OCI Podman containers, which are basically jails, and actually improved upon it by not requiring a Nvidia driver to be installed, using the Linuxulator libraries, and actually having the ability to distribute applications as opposed to giving you a big long set of instructions you got to go through manually. It should be possible to actually create by installing the same packages that I've used for DaVinci Resolve, you can install the same packages in a container, and then you would have to, then basically it would be a matter of sort of downloading DaVinci Resolve and then sort of building it into the container. But then it should be possible to have DaVinci Resolve actually being able to easy to install on FreeBSD using Podman and having professional video editing set up without having to mess with the drivers all the time. As I said, the issue with the current setup using the jail is that you've got to have the same driver installed in the jail as on the Freebsd host. Using Podman, we don't. It could be possible to backport things and actually update the jail setup so that I use the same technique that I've discovered on Podman of mounting the Nvidia drivers in the jail rather than installing a driver. So that should also be possible. But as I said, I think using Podman for these kind of things is actually going to be better than setting up Linux jails, because you've got to do more. You've got to do more donkey work to actually get this set up. You kind of got to install things manually. There isn't a way to sort of automate the installation of packages and setting up different files and that kind of thing, whereas you can do that with Podman and just be able to pull down the files, build the images, and you'll be ready to go. So yeah, made a lot of progress. I've only been back on FreeBSD for about 2 weeks after using NixOS for must be about a year. So yeah, still got it. Still got my FreeBSD touch, and yeah, a lot of progress. And said the next step's going to be having a look at getting Firefox running, because that's, I think, something that the community would benefit from, in having a version of Firefox with DRM playback and full ad blocking capabilities, as opposed to faffing about with kind of workarounds that are a bit flaky and tend to break. You would have a proper Linux version of Firefox, and yeah, that would be good. And then they said the other applications, things like Alarma, WhisperX, Handbrake, all those kind of things. And as I said, my idea would just be to sort of build a Git repository with the configuration files for the different applications, that you just clone the repository and then build the things that you want, so that you've got your own Podman images, and you know, you can just tear them down and bring them back up, and using the Podman, using a env file would allow you to sort of specify options for the container, as say the UID, your username, but also directories that you actually want to mount. So in my case, I was just using the mount directory, but for Firefox, obviously, what we would have is a downloads directory. So we could have host download, you know, or host directory or something, and that would be set to downloads, so that any files downloaded with Firefox would show up in your downloads folder on FreeBSD, because they're mounted. Obviously, the thing is, if you're uploading files, you'd have to put them into you wouldn't have access to the rest of the file system. But actually, that is a benefit. You could just copy them into the downloads directory and then upload them. But what this also means is it's more secure, because Firefox would only have access to the downloads directory that you've mounted from FreeBSD. It won't be able to see the rest of the system. So that's an additional benefit, is that you'd actually have a more secure browser than FreeBSD. The Firefox uses the XDG portal to request access to different files and stuff. So it doesn't, even though when you do open in Firefox, you can see everything here, you've kind of got to give it permission to actually use files. But Firefox in a container would only have access to the downloads directory on the FreeBSD host. So would actually be improving the security as well as enabling DRM playback. So Still working on my notes, but what I'll do next is give Firefox a shot. And I don't see any reason why it shouldn't work. I would have thought the DRM playback should work as well, hopefully. But I won't find out till I give it a go. And now that I've actually got this set up, all I actually have to do is append Firefox to this list, rebuild the image, change the entry point, and well, I'll change the entry point once I've got it working with a desktop entry. But for the initial testing, I'll still go to a bash shell, and then I should be able to basically run Firefox inside the container, and it will open up the Firefox window using the Wayland socket. The audio will come out through the Pulseaudio socket, and because we're using sockets, there's no latency whatsoever. It's instantaneous. So there's also the advantage that we've already got hardware acceleration working. So the video will be hardware accelerated. It won't be using the CPU. We've got direct access to the GPU. So it should all be good to go in theory. But as I said, it's all theory till we actually get to the nuts and bolts and actually give it a go and see if it works. And that's the nice thing about these kind of experiments and playing around with things is you go through and it takes a bit back and forth getting things working, but then finally, especially with things that use video, you go to run a command and then suddenly you get a window up and the audio's coming out and it's like, eureka, it actually works. So as I said, just for the last time, FF Play, Agent 367, Barbershop. And as I said, because I have Pulseaudio volume control open, the audio is kept alive. And there we go. This is a native Wayland window on Freebsd using the socket with the audio coming out the Pulseaudio socket as well.
This is 327. I'm going in.
There we go. There's the shortcuts. So you can see it playing back perfectly,
Yes,
no issues.
please.
Perfectly in sync. So as I said, perfect playback, no stuttering, no audio sync issues, no glitches. So there we go. Good progress. Took a while to get to that stage, as these things usually do. Takes took a lot of working out to come up with all this. But now that I've got a sort of superior method of creating the containers with the env file, the Docker file, and the compose.yaml file, which I was just using previously in the other video. And the issue with having everything in the compose.yaml file is you had to build everything every time you started it up, which is crap. But now basically what I have is, come back to the desktop, my notes. I build the container once, then I just run doesnt. So what I can do is if I come out here, guys, Podman up into the container, FF Play. Yeah. So nice and easy. Let me just check the Git status. I must have modified something in the compose.yaml file. But yeah, guys, Podman compose down. So yeah, all working perfectly now. see what I changed in here, make sure I haven't broken it. But yeah, making progress. And as I said, the other advantage that I've come across is we have the same user and user ID in the Podman container as on the FreeBSD host, as I said. So that's nicer than having something called like Rocky or Podman or something in the container. And it ensures all the permissions are bang on between FreeBSD and the container. So I'll upload this video. I'll carry on working on my notes, and I'll crack on with Firefox and hopefully be able to report back and hopefully get DRM playback working, and then look at other applications that might be useful on FreeBSD that are currently either too old or don't work. But yeah, this should mean that we can actually get all the AI applications working. We can get things like Kokoro, which is a speech to text to speech. I forget the other one. There's another one that was really good that got covered recently, but I didn't have enough VRAM to actually run it. But it means that we can run things like Comfy UI, Stable Diffusion, text to speech models, voice cloning, all that kind of stuff. And obviously it's going to be better if you have a more powerful GPU than I do, but yeah, what are you going to do? So I'll carry on cracking on with this, and yeah, the end goal, as I said, to create a repository of different applications that you can pull down and build yourself, and provide all the sort of documentation and links to the different option configuration files that you need to set up. But it's not too bad. It's not too bad to actually sort of get this stuff set up. On the FreeBSD side, there's sort of various things you need to actually do. But once you've actually got Podman set up, it's fairly straightforward, and it will be quite easy to actually just clone the repository, pull down the image, build it, enter the image for command line applications, or have desktop entries to actually launch things from the FreeBSD side. So that'd be another thing to look at, the best way to actually use desktop entries and actually start the containers, check if they're running, and then run the sort of the application inside the container. But yeah, good progress. I said I've only been back on FreeBSD for 2 weeks, so not bad going, if I do say so myself. And yeah, I'll crack on with other stuff, and any suggestions as to things that you would particularly like to run on FreeBSD that aren't currently possible but would be using a Podman container, let me know, and I can always sort of create as I said, a Git repository full of different applications using Linux Podman containers, which will, as I said, have Cuda support, hardware accelerated video playback, Wayland, window, Pulseaudio, and I can also set it so I can give you the options for X11 if that's what you use as well. So I hope that's something that's interesting and going to be useful on FreeBSD. So we will basically have everything they've got on Linux. So sometimes you get these things like people saying, I've left I mean, I actually left FreeBSD because of lack of CUDA support. You you get people say, I wish I could run this, but I had to switch back to Linux, and I miss FreeBSD. So hopefully this will stop people leaving the community, and we'll be able to have access to things that we previously didn't. All the AI stuff, DRM playback, Comfy UI, Stable Diffusion, latest version of Llama, all that kind of stuff, and an easy way to actually get it set up. So, as I said, the advantage of this, as opposed to me creating a repository for a jail where you kind of got to do a lot of donkey work and install things manually by entering the jail, the advantage of Podman is that it's easy to distribute, and actually have configuration files that you can change easily, like a .env. Where you can have actual options that you set rather than editing the Docker file or the compose.yaml file. You just edit the env file, put in the settings you want, and off you go. So that's all for now. I'll carry on working on this, and yeah, Firefox is going to be interesting. It's going to be interesting to see if that will actually work. I don't see any reason why it shouldn't, in theory. Now I've got to this stage of the foundation set up properly, it should be possible to get everything else working. But it was important to kind of test it out with these sort of options and figure things out, like actually getting Pulseaudio to remain open. That's not so much of an issue with graphical applications, but it is with command line applications. And again, the solution was actually quite simple. Just open Pulseaudio volume control, and that starts Pulseaudio open, starts Pulseaudio and keeps it open while while you're using command line applications like ffplay or whatever. As I said, I've got, I won't show you now, but several of my scripts actually use ffplay for like the scopes or a volume meter, an EBU meter. So that's why I wanted to actually figure out the command line stuff first before I moved on to the GUI applications, which I'll now do. So that's all for now, hour and a half. Hope you managed to follow along. And yeah, I've only been at this for a couple of days. So yeah, making good progress. And Firefox is on the next to-do list. So that's all for now.